data science stream. Yeah, so basically, yeah, okay, so you will meet me in several statistical courses during your four-year period with us, okay? Yeah, my contact details are here, the email, and your batch reps have my phone number as well, okay? So we will meet you at university one day, okay? Yeah, okay, so that's about myself. Well, now before going to the kind of the topics that we are going to discuss today, I just want to kind of give you a kind of a bit overview again. Now, Dr. Sandun, he covered the first part of this whole course module. So I'm doing basically the second part. So I hope you know you are doing the new curriculum. So we did a curriculum revision from your intake. So you are having a completely new curriculum, and from your intake, we are having a new curriculum. Okay, so I hope you know where you can find whatever the informations. Whatever the informations that are related to you on our undergraduate studies, the website. So you have the syllabus here. I hope you know this one. Huh? I don't think that this is the first time that you are seeing this website. So you can, here you have the curriculum, new curriculum. Okay. So, new curriculum there. Okay. So I hope you already seen the materials that I have uploaded on your course page. I have given you the link to our one of our textbook that we are using in this course, and in your second stat course as well. Dr. Tiloka will she will do the second course module. So basically, she will also use this textbook as well. Now, this is a kind of a bit new version. I think we are having 15th edition as well. So I just kind of give you the link. You can. So this book is available in library, so you can check in our library. I also checked whether we can download a PDF version from, whether we can download a PDF version from online, but it's not available. But we can download the 12th edition, and it's not kind of good to upload on this kind of online platform on Moodle. I will share that kind of the 12th, I think 12th edition with your batch reps. Then they will share you the book. Okay. Yeah, so this is the main reference that we are using for this course. Dr. Sandun also used this the book to kind of design his material. So I'm also using this one. Okay. Yeah. So today we are going to start I will come to that one. Okay, so we have a couple of activities here, and I'm going to kind of give you an overall idea about R as well. So let's jump into your syllabus. Yeah, this is the course module for you for the probability and statistic for business one. Okay, so as you know, we are having 2 hours of lectures, 2 hours of labs and the tutorials, and self-study. So you see here, it's the 90 hours. Okay, 90 hours. It's a lot, right? 90 hours. Self-study hours are given for the semester. Okay, this is the whole semester. So you can divide this one by 15 to see how many hours that you need to spend for a week. Okay, so now here, these are the learning outcomes. So you see, we are having the last learning outcome as the make use of statistical software, especially R, Python. Python, it's a kind of another programming language, but R is specially designed as a statistical software, or it's also a programming language. We can use for statistical data analysis. You will use R a lot during your 4 years. You will use R in econometrics, in probability and stat2, in multivariate, yeah, and even in machine learning. Okay, so Python, you will anyway use Python in machine learning, deep learning, and in database management and so on. Now in programming, not the database, in programming. So you will use Python R a lot during these 4 years. So you need to get familiar with with those tools as well, because you are doing business analytics. It's a kind of the it's there you need to kind of learn. You need to learn how to use these tools to do the data analytics. Okay, it's up to you to kind of, I mean, we are giving you the basics, but it's up to you to kind of get familiar with those software as well. Okay, now Excel is a kind of a basic. We hope you already know how to use the MS package. So we are not that much using the Excel, but we will give you the basics about this kind of the softwares as well. Okay, so now in your syllabus, we have basically 6 topics. So Dr. Sandun has already covered the first 3 topics, which comes under, basically you can say, which comes under descriptive statistics, and you have discussed kind of the basics of basic statistic and basic probability. So, this is basic means we have the advanced as well, but we are not discussing that kind of materials with you. We are giving you the basics to kind of get familiar with the materials that are related to business analytics or the data analytics. Okay, so basically, he has covered, Dr. Sadhun has covered these first 3 topics, but he mentioned that he didn't cover this normal distribution, which comes under continuous distribution. It's a continuous distribution. We will discuss that one. He didn't cover that one because anyway, we are using this normal distribution under this sampling distribution. So that's why we are going to discuss it. And then you with me, you will we will cover the last 3 topics. These last 3 topics basically comes under inferential statistics. I hope you know there are 2 main areas, descriptive and the inferential statistic. Basically, the first 3 topics comes under descriptive, and the last 3 topics comes under inferential statistics. Okay, so I hope we have time to start these sampling distributions as well. Okay, so that's kind of the basic overview. Then yeah, this is the textbooks, Darune. So I will share this textbook with your batchmate. Then they will share this one with you. I will share this one with our WhatsApp group. Okay, so you see we have all the topics here. Let me go to this content. Yeah, okay, so the brief content. So basically, you have already covered up to this 5 chapters in this textbook. And we are going to discuss up to these next 4 topics. And then the next couple of topics you will discuss under probability and statistics for business 2 module with most probably with Dr. Tiloka. Okay. Okay, so that's the kind of the brief introduction. Okay. Yeah, I have given my email address here as well. And please now, as we are meeting online, so I cannot see your faces, Darune. So please stop me. And if you have any questions, please stop me and ask, or you can even use the chat uh, to kind of type your question. But I prefer you stop me and ask the question, then we can discuss that question in detail. Okay, don't just listen and just look at the slide. And now what you need to do, so now you are doing, when you are doing your self studies, first try to kind of write the things that are given on the slides on your notebook, okay? On your, I mean, use a pen and write the things on your notebooks. Then you will see, I mean, then you will get the kind of the idea or the concept behind. So otherwise, if you're just looking at the slides, then it won't help that much to kind of digest the idea behind the concepts or the topics that we are discussing here, okay? Okay, that's a reminder. Okay, so these are the three topics that we are going to cover in part 2. Okay, so basically we are going to start the first topic today, and with introduction to R as well. Table of contents. So I will quickly go through the previous topics, that Dr. Sandhu has covered. And then we will start the continuous probability distributions. Here, actually, we are only discussing the normal distribution, but you need to understand there are a lot of discrete probability distributions, continuous probability distributions, but we are discussing a very specific number of distribution. This, I think, in the discrete probability distribution, you have discussed only 2, and the continuous, we are discussing only 1. Okay. Okay. So yeah. So let me quickly go through what is data analytics. Now I know we have FSM students as well, so you are also kind of going to do, or you're also going to apply things that comes under data analytics. So don't worry that if I have if I miss your specialization on your on our slide. So anyway, so data analytics, it's basically examine our data to get an answers or to identify the patterns and making decision or getting the meaningful decisions or the insights. So basically, if we use this data analytics in business application, we call that as the business analytics. Okay. So now, so we are going to kind of use a wide range of tools and platforms. You know how to use Excel. You will discuss, you will use Power BI, Tableau, and whatever the other tools comes under different modules that help in business analytics or the data analytics in business. Okay. So basically, those tools and platforms we use to kind of explore the data to get an idea about or to get an idea about our whole data set. Basically, we are using these tools for data visualization, and there are advanced techniques as well, the algorithms, machine learning, deep learning. So such processes or such algorithms or the techniques we use to kind of basically doing the advanced kind of the analytics steps. So, so I have a small video here, YouTube video on business analytics. It's from Harvard Business School. So you can go to this video. Okay, so you can simply click this link. Just click this topic. Yeah, then it will direct you to this video. Okay, so let's quickly go through this one. Okay, so basically, I mean, you can go through the video again. So basically, in data analytics or in business analytics, we have basically four types of analytics: descriptive, diagnostic, predictive, and prescriptive. So during your 4 year of degree, you will see the tools, techniques that comes under each of these and each of these type, each of these each type of these each type of this analytics. So basically, now descriptive analytics. I hope you are now a bit familiar from this our first module. And now, so in the descriptive, now you see, so we have on the y-axis, we are having the difficulty level. So you see the difficulty level goes from lower end to the upper end. So basically, the descriptive analytics, we are having our, I mean, we are using our data. We are using our data and we are looking at I mean, we are trying to kind of understand the data using a visualization and using summary values likewise. Okay, so the so here the data visualization is a kind of a natural fit for kind of communicating this descriptive analysis, because we know charts, graphs, even maps can show the trends in data, yeah, as well as the dips and spikes in a kind of a clear and easily understandable way. Okay. Then the diagnostic analytics addresses the next logical question: why did this happen? So basically, so taking the analysis to this step, we are having, I mean, basically what we do under this diagnostic analysis, we try to kind of compare coexisting trends or maybe the movements and try to kind of uncover correlation between the variables and determining causal relationships where possible. Okay? So basically, you will use the tools and the techniques under diagnostic analytics in mainly in second, third, and fourth semester as well. And the predictive analytics, so predictive analytics here, what we try to do, we try to kind of see the prediction about the future trends or the events. Okay, so what we do there, we analyze historical data and we try to kind of get a prediction about what the future could hold. Okay, so basically, that's what we are doing using algorithms, machine learning algorithm, deep learning, whatever the kind of the multivariate tools. Those comes under the predictive analytics. And the prescriptive analytics, it's the kind of the final kind of the steps. So in the prescriptive analytics, it takes into account that all possible factors in a scenario and suggests kind of the actionable takeaways. So this type of analytics can especially useful when making our data-driven decisions. So basically, you will discuss a couple of tools and techniques in your operational research course modules that comes under the prescriptive analytics. So you will see during your 4 years in university, you will cover almost, or not almost, but basics and advanced tools comes under each of these types of data analytics. Yeah. So and you also need to do your self studies as well if you want more detail about those techniques. Okay. Then now this part. Why study statistic? You already know. Okay, so I just want to kind of include this one to kind of give you an overview. So basically, now you should understand. Now here in this the baseline of these 4 types of data analytics is stat and math are the base. Actually, stat is also a mathematical science. It's a kind of a branch of mathematics. So stat is also, I mean, we are not going to, basically we are using or we are discussing statistic in an application as application method or in an applied way. I mean, we are discussing applied statistic with you, but you should know that we have theoretical statistic. That's what I did in my PhD, theoretical statistic or the mathematical statistic, where we develop the tools comes under statistics. Okay, so that's where we need kind of the special materials comes under mathematics, because we need the math base to derive the test. So you will see, I mean, when we are discussing the hypothesis testing, those tests are derived using mathematical knowledge. Okay, so yeah. So anyway, so we are discussing, or we are applying statistics in a very applied way with you. So you don't need to worry about kind of theoretical background. So yeah, so that's why in your first year, we are giving you the basics in statistics, basics in mathematics, basics in programming, to give you to make you kind of the understandable one in to touch these 4 types of data analytics. Okay. So yeah, so basically statistic, we use statistic to transform our numerical data into meaningful insight for decision making. Okay, so you have already now discussed several tools comes under statistic. Okay, so I just include whatever the stuff that you have already discussed. Now, there are two main branches of statistic, descriptive and the inferential. I will come to this one again when we are discussing, when we start discussing sampling distributions or the sampling methods. So basically, descriptive statistics, there we use descriptive measures, summary measures, and visualization to kind of get an idea about our data. And the inferential statistic is this statistic where we use sample data to say something about the bigger picture or the population data. Okay, so that's where we are going to use all the testing procedures. Okay, so yeah, descriptive statistic basically organizing, summarizing, and presenting data in a clear and informative manner. So we use frequency distribution, charts, summary measures. Now you have, I saw that you have discussed histograms, bar chart. There are a lot of charts that comes under actually the data visualization. I guess you will discuss that one in your fourth semester. In your second year. Yeah, so you will discuss a lot under data visualization, where you will discuss a lot of visualization tools using different softwares. Yeah, what are the summary measures means? Basically, calculating the sample mean, sample variance, quartiles, 5 summary measures. Okay, so we can all of these visualizations and summary measures, we use our historical data to see or to get an idea about our data set. So all of these tools comes under descriptive statistics. Then the inferential statistic, there we use the sample data to draw conclusion or the make prediction about the population. So here, this is the branch that we are going to use testing procedures. Basically, the point and the interval estimation, hypothesis testing, event regression, time series, multivariate, machine learning, deep learning, whatever the techniques that comes with whatever the materials that we use, whatever the tools that we use to kind of make predictions or get decisions about population. Okay, so here, basic vocabulary of statistic. I just want to include this one because we will use these terms again and again in sampling and sampling distribution. So let's quickly go through this one. So variable or a random variable, it's a characteristic of an individual or item. For example, you can say, okay, weight of a student in our intake 2025. Okay, so it's a kind of a characteristic of a student. Okay, it's a kind of a variable, or we call that one as a random variable. So usually we use these capital letters to kind of represent a random variable. Then a distribution of a variable is it's a kind of a description how often each possible value that a variable can take in a data set. So basically, we have values for a given random variable, and we have kind of the probability for each value. So basically, that probability or the distribution of those probability values gives the distribution of, as we can define it as the distribution of a variable. So, so basically, we have two types of distribution: continuous and the discrete. I will come to that part. So the data are the observed values of the variable. Now, let's say if you take weight, so we can take 70 kilograms or 65.2 kilograms. So those are the observed values of that variable. We can take whatever the values as whatever the relevant values as weight. So those are the data. If we consider single observed value, we call that one as the data. Okay? Then in statistic, we have basically two groups. Population, that's the bigger picture, or that's the complete collection of the individuals or the items. And we have the sample. Sample is a subset of the population that we use to study the population. Okay, so because the population is a kind of a bigger picture, it's a collection of all the individuals. We can't collect all the individuals or the items. It's a kind of a costly method and it takes time. So therefore, instead of considering the whole picture, we take a subset of that population, which we called as the sample. And using the sample data, then we are going backward and we try to kind of generalize whatever the information that we get from the sample to the population. That's where we are using the inferential statistics. So when we are working with sample data, we call, descriptive statistic is the part where we deal with the sample data. Then the sampling, we are going to start that topic today. So sampling is used to kind of, we use sampling methods because studying the whole population is too costly and time consuming. So therefore, instead of kind of studying the whole population, we study the sample. But the thing is, when we are selecting or when we are getting that subset from the population, we need to have a kind of a proper technique to kind of get a subset from the population. So that technique comes under the sampling methods. So the sampling method is a kind of a very vast or very kind of vast area in statistics, but here we are also giving you the basics. Okay. So then the statistics, it's a numerical measure or the numerical summary that describe a characteristic of a sample. Okay, so you need to understand the. So we will come to this one again under the sampling under the sampling method. But let's quickly go through this one. So you need to understand the difference between statistic and parameter. This is not statistics. This is statistic and parameter. So statistic is basically a numerical summary or a summary measure that describes the characteristic of a sample. So statistic simply comes with the sample data. And the parameter, it's a summary measure that describes the characteristic of the entire population. So the parameter is a summary measure or the descriptive measure comes with the population data. Okay, so that is the main difference. So statistic comes with the sample data, parameter comes with the population data. Then we can prove actually, we can show that most of the time the statistic that comes with the sample data will be an estimate of the corresponding population parameter. For example, we can say sample mean is an estimate of the population mean. Or we can say sample variance is an estimate for the population variance likewise. Okay, so we have a kind of a relevant statistic as an estimate for the corresponding population parameter. Okay, so we will discuss this one under the point estimation very briefly. Okay, so then so one of the main concern in statistic is determining how well a statistic approximate its corresponding parameter. Now, so statistic, we know now statistic comes with the sample data, parameter comes with the population data, but we can use the statistic as an estimate for the parameter. But the thing is, we need to know how well this statistic approximates its population parameter. Okay, so this quality of approximation depends on our selection of the sample. Okay, so that's where we need to apply the sampling method in a correct way. So simply we need to have a very kind of a representative sample. So representative sample means a sample that accurately reflects the characteristic of our population. If we don't select a correct, or if we don't select if we cannot get a representative sample, then it won't represent our population correctly. It will be a kind of a biased sample. Okay, so I mean, if you use that kind of a biased sample, then we will not be able to kind of get correct conclusions. Okay, so yeah, so today we will discuss a couple of sampling methods that we can apply to get a representative sample from a population. Okay, so yeah, so then the inferential statistic, basically we use, I mean, in inferential statistic, we use sample statistic to draw the conclusion about the population parameter. Okay. Okay, so yeah, so here you have basically it's a small exercise for you. You are given a study and you need to kind of match each of these items with the given description. So here you have the description, and you can select all students who attended the college last year is what, whether it's a population or sample or whatever. Okay, so so you need to read the study, you need to understand the study, and based on the study, you can match each of these items with the following description or the given description. Okay, so try to do this one. I'm going to kind of skip this kind of the practice exercises. Okay? I mean, I will discuss, but it's a kind of a basic, and you already know the meaning of these terms. Okay? Yeah, then types of the variables. Basically, we have two types of variables: numerical and categorical. Numerical, we call that one as quantitative. Categorical, qualitative. So numerical variables, there we have kind of some value. Okay, so it represents quantities. So the numerical variable, we can divide numerical variable further into discrete and the continuous. Now, discrete means we are having kind of the specific values, for example, kind of specific numerical values, let's say 0, 1, 2, and 3 kind of. Then the continuous variables, we have kind of, we can take whatever the value within a given range. For example, height, we have kind of a decimal values as well. Let's say now the weight of our intake 2025 students, we can say, okay, the weight is in between 50 kilograms to let's say 70 kilograms. Okay, so likewise, within that given 50 to 70 range, we can take whatever the value as a weight, as a value of that variable weight. So this is where now, if you have a discrete variable, and if you have a probability for each of these given values, then we have a probability distribution. That probability distribution, we call that one as the discrete probability distribution. And when we have a continuous variable, and let's say we are having kind of a mathematical expression for that continuous variable, then we call that one as the probability distribution of continuous variables. Okay, so we will discuss, let's look at few distribution comes under discrete and the continuous. Then the categorical, it's basically we are having kind of the items or groups or categories. So categorical variable, we can further classify that one into nominal and ordinal. Basically, nominal is a variable where we have the categories without any specific order. For example, gender, hair color, blood type. The ordinal variables compared to the nominal, in the ordinal variables, again, we are having the categories, but we have kind of a specific order. For example, we can say education level, high school, bachelor, master's, PhD. So you see here, we are having a specific order here. Okay, or even the satisfaction levels from extremely dislike to extremely like, or even we call this one as a Likert scale variable as well. A Likert scale, let me write, not sure whether you are hearing this one the first time. So we call this one as the Likert scale. Likert scale variable. Okay. So here we are having order, or in the ordinal variable. So now, we should understand we do math or stat, or we calculate mean, variance, whatever the stuff, or we create plots, charts. Basically, mainly, I mean, we do math, not the plots. We especially do math or calculating mean variances with numerical variables. We don't calculate mean variances for a categorical one. I mean, we can find the frequencies, how many categories or how many values we have with each of the categories, but we don't do any kind of the math or the we don't calculate any kind of summary measures there. It's a kind of a no sense. I mean, it's a meaning. There's no kind of the a meaningful kind of the value if we use. I mean, if we calculate the average standard deviation with categorical variables, but we can do the plots. I mean, even we can do the plots with numerical variable as well as the categorical variable. So you will discuss all of these visualizations under the data visualization, but I saw you have discussed a couple of tools, the box plots, histograms, pie charts I haven't seen, but yeah, so bar charts, okay, and the scatter plots kind of charts. So yeah, okay, so that's basically, let me erase, basically the kind of the types of variables. Okay, then with that, you have already covered organizing and visualizing data. Basically, you have discussed frequency tables, box plots, bar chart, histograms, so on. And then you have discussed numerical, descriptive or the summary measures like calculating mean, variances, quartiles, quantiles, quartiles, and then what else? Five summary measures, calculating the correlation. Okay, so you have discussed how to calculate the summary measures, and you have covered basic probability and even the descriptive probability distribution with Dr. Sandhu. Okay, so now, before jumping to continuous probability distribution, let's quickly go through discrete probability distribution as well. Then we kind of almost have a kind of a good overview before jump into the second part. Okay, so now you know we have basically our one type of variable is the numerical variable, and we know the numerical variable divided into two categories, discrete and the continuous. So with the discrete random variable, we can define a probability distribution. Simply, the probability distribution for a discrete random variable is a kind of a list of all possible values along with the probability of occurrence of each outcome. So if you look at this table, so here we have the probability distribution of the number of interruption per day in a computer network. So when the interruption per day is 0, the probability of having 0 interruption per day is 35%. So having a probability of having 1 interruption per day, 25%, and so on. Okay, so this table gives us simply a probability distribution for a discrete random variable. Why this is a discrete? Because you see interruption per day, we are having specific numbers. And here we are having the probability of occurrence of each of these events. Now, you know, one of the characteristics of a probability distribution is the sum of all the probabilities is, or the total will be 1. Okay, so that's the characteristic of a probability. It's a characteristic of a probability. Kind of one moment, Darune. Let me so I'm not sure why I'm sharing. One moment, I need to change a setting in Zoom. Give me one moment. Okay, so yeah, so so this table simply represent a probability distribution. Okay, the sum is 1. Then this is kind of the graph of that distribution. So you see we are having on the x-axis, we are having interruption per day. On the y-axis, we are having the corresponding probability. Okay, so it's a kind of a bit decreasing kind of the probability distribution. Okay, or it's a kind of a bit. It's a skewed distribution. Skewed distribution. So we can draw or we can draw a probability distribution once when we know the probability and whatever the probability and the relevant values of the random variable. Okay, now here the height represent, now in the discrete probability distribution, simply height represent the probability. Okay, height represent the probability. So here we can't here we don't kind of we don't draw a line which goes through these probabilities. In the discrete probabilities, that's not a kind of a common usage. So here we don't kind of draw a kind of a line here, but for the you will see when we are using when we are in continuous probability distribution, we have kind of a smooth kind of the curve. Okay, here we don't plot a curve which intersect these probability values. That's a kind of the usual way. So let me erase. Okay. Yeah, then this part is also on your last lecture note. Expected value and the variance and the standard deviation. So let's see what is the expected value. So expected value is the kind of the mean of the probability distribution. So we can define the expected value for a discrete random variable and for a continuous random variable. So here I have given you the definition of the expected value for a discrete random variable. So we use this mu, it's a Greek letter. We use this mu notation to denote the expected value or the mean of the probability distribution. Now, here we should, so I will come to that. So I will explain the stuff that I have in mind later. So so the mean is the expected value. Mean of the probability distribution is the expected value of a random variable. So simply what we do to calculate the expected value, we use this mu notation, or we can use this E of X, expected value of X. So for a discrete random variable, we simply multiply the value and the corresponding probability, and then get the summation of that product, summation of, or we sum the each product. Okay, so for the above, for the previous example, what we do, we multiply the 0 times 35.35 plus 1 times 0.25 and so on, okay, to get the expected value. Okay. Then the variance. So basically, this expected value or the mean gives us the kind of the center of the probability distribution. So this is if you remember from your previous materials, you have measure of central tendency. Measure of central tendency. Measure of central tendency means we are looking at the middle part of the whole data set or whole distribution, say in here. So the mean is one of the measure of central tendency, where we are looking at the mean part or the average value of the whole probability distribution. Then this variance and standard deviation are the measures of dispersion, where measures of dispersion, I hope you know these terms. It's already kind of discussed. Okay, so you can go to, I think it's under first or the second lecture notes. So please go through those ones if you don't remember the terms. So the measure of location, let me write it. Okay. So let me write here. Okay, so let me write here. So we have different measures. So measure of central tendency. Okay. So basically, mean comes under the measure of central tendency, and mode, even median. Okay. Median. And then we have measure of dispersion, where we are using here we use variance and standard deviation. So simply these two measures, we can use these two measures to say something, to measure the spread of our data. Okay, to measure the spread. Now, spread means, now let's say we have a data set like this. Let's say we are having a data cloud. This is one cloud. And let me consider another cloud here. Okay. So this is the first cloud and this is the second cloud. Now, basically, what we do using the central tendency, we try to kind of find the mean or mode or the median of this data. So let's say here, let's say we are having mean here, mean, okay, mean. And we can find the mean here, mean of this cloud as well. Let's say mean somewhere here. Okay, and then dispersion, the measure of dispersion, that's variance and the standard deviation. What we try to do, we are try to measure the kind of the spread of this whole data set or spread of this data cloud. Simply what we do here, we are kind of measuring the distance between each of the data set, each of the data point and the mean, and then take the average. Basically, we are take the distance between each data point and the mean, and then take the average. So let me take the distance D1, D2, D3, and then we take the average of these distances. So this will be simply the standard deviation. Okay, standard deviation. I mean, if you take the square root, likewise. Okay, so now you know. Let me write the variance. Variance of x. Simply, you know, variance of x will be 1 over n minus 1 xi minus x bar squared, right? This is the variance equation, right? You know this one from your previous one. So here we have simply the difference between each data point and the mean. This is the mean, sample mean. Okay, so simply we can write here I goes from 1 to n. This is di, difference square. And then we are taking this, simply we are taking the average. I mean, average, this is 1 over n minus 1. Don't worry. And this can be 1 over n as well, but don't worry about that one. Anyway, we are taking the average. So average of the d. So here, better if I write here squared. Then the standard deviation will be, you know, it's the square root of this average. This average. Okay, square root of this average. Right? So simply, this is, we are taking here the average of this, whatever these squared values. Right? So simply, now you see here, so now if you take the let's say here we are having a standard deviation. Now you see here the data points are very close to the mean. Data points are very close to the mean. So therefore, this difference is small. Now here, if you look at the second data cloud, here we are having the difference between each of the data point. Oh, sorry, mean is here. Sorry, mean is here. So we are simply find the difference between mean and each of the data points. Okay, so here. So here, now if you look at this difference, so here we are having a bit large difference. So by looking at this, you calculate the variance, we will have, so let me take this one as the first data cloud and this one as the second data cloud. Tell me which one has the large, or which one has the large variance. You can type the answer. Which data cloud has the large variance? Is it the first cloud or the second cloud? What do you think? Let me see the answers. Very good. Yes, the second cloud. Yes, Darwani. Very good. Very good. Yes, good. Second cloud, because we see the difference. Here we are having a large difference. Okay, a bit large difference compared to the first cloud. Okay. So anyway, so this measure of dispersion, it's the measure of spread. Simply dispersion. We call this one as the spread as well. Spread. Right? Okay. So yeah. Okay. So I hope it's clear to you. Okay, so yeah, so now similar to these measures, we can define the variance and standard deviation for a given distribution as well. Okay, so let me erase this one. So the variance and the standard deviation for a given distribution will be, we use this sigma squared notation. It's also a Greek letter. Sigma squared for the variance of x. It's simply this formula. You can use the expected value of x squared minus the square of the this mean square of the expected value of x. Then the standard deviation is a square root of variance. We use this sigma notation. Okay, so yeah, so to calculate the variance and the standard deviation for the example that we used earlier, you can refer your lecture note. Dr. Sandun has already kind of used the same example, so you can go through that one and see how to calculate, how you calculated this variance and the standard deviation for a discrete random variable. Right? Similarly, we can define the variances, mean variances, standard deviation for a continuous random variable as well, but with some integral notation. You haven't discussed any integration yet, so therefore we skip that part from stat module 1. Okay, so then, yeah. Now, so you have, so we are discussing only two types of discrete probability distribution, binomial and the Poisson. Those are the distribution that we are discussing under your syllabus. So binomial, I don't need to kind of go through all of these. What we do using the distribution, we are simply we try to write or get a mathematical expression or a mathematical model that represent our variable. So once we know a mathematical model, or once we have a mathematical expression, then we can simply use that model or the expression to calculate the probability of occurrence of whatever the given outcome. Okay? So binomial distribution is one of those mathematical models. So we have basic properties, basic characteristic when we are using the binomial, or when we are use a binomial distribution to model our variable or model our outcome of a given variable. So you can go through that one. So here, if we take X as the number of events of interest in a sample, where X can take the value from 0 to n, we say X follows a binomial distribution. So for each of the distribution, you should understand for each distribution, we have parameters. Now, parameters, you should understand parameters are the values that are defined on population data. Okay, so simply here, these distributions are we are using this distribution, or we define the distribution, or we use this model on population data. Okay, so you should understand that one. Now for any given distribution, we are having some parameters. Now for the binomial distribution, we are having two parameters, n and p. N is the total number of outcomes in the sample, and p is the the probability of success. Okay, so if X is if our variable follows a binomial distribution with parameter n and p, we can write this X follows, this tilde notation is to follows binomial with n and p. Okay, now, for the discrete, if you want to define a distribution for a discrete variable, we call that probability distribution as a probability mass function. It's a different name. We are giving a probability mass function. So the mass functions are for the discrete. Then the probability density function, PDF, are for the continuous variable. So here we have the mathematical model for the binomial distribution. Now, so this is where we are using mathematical statistic or the theoretical statistic. I mean, we are not discussing how to derive this one, but I mean, someone has to derive. So there we use math and theoretical stat. Okay, so using now, we have some expression or some model, mathematical model. Now we can use this model to find probability. Okay, so the expected value and the variance of this binomial distribution will be simply the NP, the number of total number of or the total number of elements in the sample time, the probability of success, and here you are given the variance of X or the variance. Okay, and the standard deviation will be the square root. So now I'm going to skip this part, otherwise it will take time because you already discussed the examples already. Miss Uttara also discussed questions with you. She already covered the tutorial questions as well. So therefore, I will skip this one, but you can go through these examples. Okay. So I have given you how to calculate the binomial or how to use the binomial model to find the given probabilities. Okay. And then the Poisson distribution, it's again a discrete probability distribution where we use it to model the number of events occurring in a fixed time interval. So we try to use this to kind of model the number of events occurring in a given or occurring in a fixed time interval. So there we assume the events occurred in the that interval, the time interval are, the events are kind of independent, and we are having a kind of a constant average rate. So those are the assumption when we are using the Poisson distribution. So here also we have a couple of properties if you want to kind of model our data using Poisson distribution. You can go through these ones. You have discussed these ones as well. So the Poisson, their x, our variable x will be the number of events occurring in the time interval, given time interval. Then we called x follows the Poisson distribution. So in the Poisson distribution, we have only one parameter, lambda, but in the binomial, we have two parameters, n and p, but in the Poisson distribution, we have just a one parameter lambda. This is the kind of the average rate or expected number of events, or the average, this constant average rate. So we can denote x follows Poisson lambda. Then here the probability mass function or the model is given here. So here this E is actually the exponential function. It's better if we write this one as the exponential. Anyway, this E, you should remember this E is the exponential. This is the exponential function. Exponential functions you will discuss maybe in Math 1. Yeah, I think you should discuss this one in Math 1. We write this one as the exponential. Exponential, let's say n. Okay, exponential n. Or we can write this one as this is a function e to the n. Okay, so when n equal 1, we can find e to the 1. I mean, in your calculators, on your calculators, you have this exponential e to the 1 simply. This is the value e to the 1, 2.71828. Likewise, you can find e to the 2 and so on. Okay, when n equal to. So here we have e to the 1 here. E to the 1. I will update this one a bit. It should be e to the 1. And so here we have exponential. Simply we have this exponential minus lambda and lambda to the power x over x factorial. Okay, so this will be the Poisson model or the Poisson distribution where x goes from 0 to infinity. So this lambda is the expected or the average rate. Okay, and once we know the model, we can find the expected value of the distribution and the variance. So you see here, mean and variance are equal in the Poisson distribution. That is one characteristic. Another characteristic of the Poisson, mean and the variance are equal. Okay, but if you look at the previous binomial distribution, we have different expected value and the variance. But for the Poisson, we are having same mean and the variance. Okay. And the example is also given here. Okay, so you have discussed this one as well. Please go through this one again. Okay, yeah. So we took 1 hour to kind of do the recap. So then I will take, let's take 1 more minute or a 30-second break. And then we'll start discussing the continuous probability distribution. Okay. So any questions, guys? Any clarification you want? To have any questions, you can talk, or if you can write your question on the chat, but that's not the preferred method. But if you are shy to talk, then you can use that one as well. Any question? Is it everything is clear to you? Yeah, so this is a basic, basic module, and there are a lot to discuss. That's a problem, because during the first year we are giving you kind of all the basics that you need to go with the advanced data analytics tool, even in FSM students as well. So basically, you are also using these analytical tools. Hari, okay, seems you don't have any questions. Now we are going to start continuous probability distribution. So continuous probability distribution, we define the continuous probability distribution for a continuous variable. Now you know what is continuous variable. Continuous variable is a variable that we can take whatever the value on a given interval. Okay? We can have decimal values or the floating point values. Okay, now as a continuous distribution, we are going to discuss normal distribution. This is a kind of a special distribution, a special. Okay, I have a question. Let me see. When you teach continuous, can you explain it more slowly? That of us. Okay. Yes. Okay. So teach continuous probability. Can you explain it more slowly? Yes, I will. I will go through. I will from now onwards. I will slowly explain these topics because these are the new topics. You haven't. I guess you haven't discussed the continuous probability distribution. So don't worry. I will slowly explain. Okay. But you can, of course, stop and comment if I'm kind of explaining it a bit fast. Yeah. Yeah. Okay. 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 So now normal. So the normal distribution is a kind of a special distribution, comes under continuous probability distribution. As I mentioned earlier, there are a lot of continuous probability distribution, but we are discussing only one. Okay. But you will see kind of the other distribution when we are discussing the testing procedures and so on. Okay, so a random variable x, now this random variable is, now you should understand, is a continuous random variable. So a random variable x is set to follow a normal distribution with mean mu and standard deviation sigma, or you can say here variance sigma squared instead of standard deviation. You can say variance sigma squared. These are the parameters. Now, here we have, for the normal distribution, we have two parameters, mu and the sigma squared. Okay, so we denote x follows or x distributed as normal in normal with two parameters, mean and the sigma squared. So this is simply population mean, and this is simply population variance. Okay. If so once x follows a normal distribution, we can define a kind of the model, mathematical model, or we call that one as the probability density function. So simply the PDF, it's a mathematical model that defines the distribution of a continuous random variable. So this is the PDF for the normal distribution. Now here you see in the discrete probability distribution, we are using this P notation. P kind of see the difference between the mass function and the density function, here we use the P notation. It's just to kind of see the, I mean, to differentiate between this PMF, the mass function and the density function. So don't worry too much about the notations here. So here we use the P, but in the continuous, we use F notation, right? To say, okay, we are having kind of a density function. So this is the mathematical expression for the normal distribution. So here we have 1 over square root 2 pi, square root 2 pi times sigma. Now here we don't have square root for the sigma, but if you want, you can write this is same as 2 pi sigma square. If you want to get this sigma inside the square root, you can write 2 pi sigma squared as well. And then we are having again this exponential function. This is simply the E function, okay, exponential to the power. So here exponential to the power, this part, minus x minus mu square divided by 2 sigma square, where the x is in between negative infinity to infinity. So we can take whatever the x value in between negative infinity to positive infinity. Okay. Yeah, so this normal PDF or the normal probability density function, it's a symmetric. So you will see in the next slide a diagram of this probability distribution. So this is the shape of the normal distribution for a different mu and the sigma squared value. So let's look at now this blue one. Blue one is when the mu is now here. You see here. You see this is the here. You see this is the mu value. Okay, mu 0. So for these blue, red, and the orange color distribution, mu is 0. Okay, so here you see. Here you see mu is 0. Okay, and for the next one, for the green color one, now mu is negative 2. Okay, mu is negative 2. Mu is negative 2 here. And we are having different variances. Now for the blue one, we are having variance as 0.2. And the red one, we are having variance 1. Okay, so you see what happened when the variances are having different values, the shape or the spread of the distribution, we are having different spread. Okay, so this is, so you see the spread of this curve. So blue one, we are having a bit smaller variance. We are having kind of a bit narrow kind of the spread. And then when sigma squared 1, we are having kind of a different spread compared to the blue one. And here for the orange one, we are having sigma squared 5. And here we are having sigma squared 0.5. Okay, so you see, based on the different mean values and the sigma values, we are having different shapes. But you see, all of these are kind of symmetric. Let me show you the what do you mean by the symmetry? Symmetry means. So now here you see. So you see here. So here let's take this blue one now. Now about this. So around this this purple color line. Sorry, around this purple color line, you see the area this side. So this is simply the right side area. And here simply the left side area. So you see simply the right side and the left side, the area is simply approximate, I mean, are the same. Okay, are the same. So we can say, okay, so the normal distribution is a kind of a symmetric distribution, and it's a bell curve or bell-shaped distribution. Okay, so those are the characteristics of this distribution, and we can say, okay, the distribution is around the mean, Okay, so let's look at the characteristics that are given in the previous slide. Yeah, so the normal probability density function is symmetric about the vertical line that goes through the mean, mu, okay, population mean. And another characteristic, the mean, median, mode, all coincide at mean. So simply, we are having kind of the same mean, median, mode for a given normal probability density function. Then the expected value and the variance for this normal distribution function will be simply the expected value will be the mean, mu, the variance will be sigma squared. Okay. Okay, then we are having a special type of normal distribution. We call that one as the standard normal distribution. Standard normal distribution is the distribution with mean 0 and the standard deviation 1. We use this notation N01. So we call this one as the standard normal distribution. If we go back to our chart here, we see this red color one, this red color distribution is the standard normal distribution, because here we have this mu equals 0 and sigma squared equal 1. So this is simply the standard normal distribution. Okay, standard normal distribution. That's a special case of the normal distribution. So for the standard normal distribution or standard normal variable, we use the Z notation, Z or the Z notation. So, Z notation, we use Z for the standard normal. Instead of X, we use Z for the standard normal. We use X for normal, or the other normal distribution, and Z for the standard normal. So, then the cumulative distribution, you know what is the cumulative distribution? So cumulative distribution, we can define cumulative distribution. We use this pi. I mean, don't worry about these Greek letters. It's a kind of the way to define this, or way to kind of, I mean, we are using this kind of a notation. Otherwise, there's no way to kind of write things in mathematical way. So pi z, what is the kind of definition? It's the probability, the z less than or equal whatever the given C value. Okay, let me explain that one to you using our standard normal table. Now let me take that one. So for a standard normal distribution, we are having Z tables. You can download it from your Moodle. So this one. Okay, so yeah, Z table. So let me choose this one. So this is the standard normal probability, or like a table that we saw for the discrete one. So here, our previous example. So here, yeah. So we are having the values, whatever the X values, and the probability. Similar, very similar to this one. We can, I mean, we have already defined a table for a standard norm. You know, if you look at this table, here we have the Z values. Now, this one is only for the positives, positive Z values, but you should understand we can have negative values as well. It's basically, there's a relationship between the positive and the negatives. I will explain that to you. But anyway, so here we are having the positive values. Okay, so here we are having the Z values. So how do we read this table? So you should understand, or you should know how to read this table, because you are going to use it again and again. So here we read, so first we read the values on rows and the values on the columns. Okay, so this here, let me write my pen here. So so here, I mean, inside this table, we are having the probabilities. We are having the probabilities. Okay, so let me write. Let me say. Okay, so let's consider this probability. 0.5. 0.5 actually, this is the probability when C less than or equal 0.00. Okay, so this one we can write 0.5040 will be the probability V less than or equal. How do we read this one? First we take the value on the row and then the value on the column. Okay, so this will be simply 0.001. Okay, here we have this one. No, sorry, this should be, sorry, make add කරන්න. We need to add, sorry. Sorry, I missed. This should be, you need to add, sorry. I also make add කරන්න ඕනේ. What you need to do, sorry, my mistake. So you need to add these. May the add කරන්න. So this will be simply, let me write here. This is 0. Let me clearly write. One moment, I will. So what I'm going to explain. So I'm going to, let's say, we are going to consider this value. And let's say we are going to consider this value. Or maybe somewhere this value. So let's try to consider those values. Okay. So now this value will be probability C less than or equal. You need to consider the value on the row and the corresponding value on the row and the column, and simply add these two. Add කරාම එන්නේ 0.00. And this value will be probability C less than or equal 0.11. Sorry, 0.1. Okay, 0.1. Then this value will be the probability. So we are considering this value and this one. Simply that will be probability Z less than 0.53. Clear, ne, Deka? Is it clear to you, Darwane? Let me consider another one as well then. Let's see this one. So this one will be simply probability C. Here we are having 1.4 and 0.5. So C less than 1.45. Hari neda? Is it clear to you? Yes or no? Just tell me whether it's clear to you or not. You should understand you should know how to read this table. Yes, okay, good. At least one. Okay, yes, thank you. Thank you, Daru. Okay, so this is simply, basically, this is the kind of, thank you. So this is the way to kind of read this standard normal probability table. Okay, so this is a kind of a standard table. I mean, we don't need to remember anything here. I mean, we will give you the table if you're going to, when we're asking question from this standard normal probability. Yeah, so now here, here we are giving only the positive Z values, but we have kind of same table for negative values as well. So let's look at the diagram, the given diagram bit. So you see here, simply this is the now this is the standard normal distribution. This is the shape. So simply we are getting this area, the area highlighted in blue color. So this is the area that we are having from this probability. Simply this is the Z less than or equals simple Z. Okay. So if let's say, let's take this one. So if probability Z less than 0.05, then the probability will be 0.5199, or we can say 51.99%. Okay, so this is the probability or the shaded area that represent this probability. Okay, so now here Z will be simply 0.05. Okay, so likewise, for any given Z value, we can find the probability, or if we know the probability, and we can go from other way around as well. If we know the probability, then we can find the corresponding Z value as well. Okay, so we use the both ways. Okay, so if we know the Z value, we can find the probability, or if we know the probability, we can find the Z value. Okay, so I hope using this standard normal distribution is now clear to you. Okay, now let's move to our slides. We will come back to this one again and again. Normal distribution. Yes, okay. Yeah, then, so that is the simply here we have this cumulative density function. Okay, so cumulative density function. Now you see here, if you go down the table, if you go down the table here, this value simply value, this is the probability Z less than or equal 3.49, if I'm correct. Let me see. Yes, 49. It's the probability Z less than 3.49. Simply, it's the region. Okay, so this is 0 here. Let's say 3.5, let's say 3.49 somewhere here. So this is the region. This is the region. Here, we are having cumulative values in this table. Okay, we are having the cumulative values because now if we consider, let's say, this value, this green one, it's somewhere here. Let's say 3 is somewhere here, 3.00. So then the probability is this one, this green colored area. It's the probability Z less than or equal 3.00. It's simply 0.9987. Okay, so you see, compared to the this probability, we are having a bit smaller one. But anyway, so when we go from 0 to this, I mean, when we are on the right hand side of this Z values, we see we are having kind of the, I mean, we are adding the probabilities together. Okay, so that's where we are having this cumulative density values, or cumulative density or cumulative distribution function. Okay. Okay, so yeah, cumulative distribution function, or the distribution function CDF, is now defined, and we discussed that. Yeah, so now I mentioned now, I already mentioned we are having kind of the same kind of the table for negative Z values as well. So using the symmetry, now we know we are having kind of the, it's a symmetric distribution. So using the symmetry of the standard normal distribution, we can simply define, the probability Z less than or equal, let's say, negative 1.95 is same as probability Z greater than or equal 1.95. Let's go to the table and see what is the value of 1.95 first. Let's go to the table. 1.95 is somewhere here. 1.95. අපි ගන්නේ 1.95 මෙන්න මේක 1.95. One moment. Let me 1.95 and sorry, let me erase this one a bit. Erase this one again. It's a bit hard when you're using this online platform. Okay, so 95 is this value. Okay, simply we are having this value. Okay, 95. Okay, let me write the value here. So simply we are having now, let me write here. Probability 1 point, sorry. Z less than or equal 1.95 is simply 0.9744. Okay, let's go back to our slides. Let me write everything in a clear way. Let me write here. So we have probability Z less than or equal 1.95, which is 0.9744. If we draw this one, let me draw the distribution. Zero somewhere here, let's say. So we are having the Z values. Here we are having the positive values. This side we are having the negative. Okay, method of positives, negatives. Now let's say 1.95 is somewhere here. Okay, so simply we are having this probability. Okay, this represents this probability. I think it's clear. Now, what we are going to do, what we are going to check, due to the symmetry, the makama, we can, due to the symmetry, let's consider the same distribution. Let's say this is 0. Now, මෙතන අපිට තියෙනවා 1.95. So here we have negative 1.95. Negative 1.95. Negative 1.95. Negative 1.95. Right? So now, due to the symmetry of the standard normal, now we know this area, then due to symmetry, actually this area will also be මේ area එක වෙන්නේ, it will be the same as this one. අපි ඒක ලියද්දී, how do we write that one in notation? Probability Z, now greater than or equal. Then අපි ඉන්නේ Z to the greater than side. Okay, so Z greater than negative 1.95. 95 will be 0.9744. Okay. Due to the symmetry, due to the symmetry, we can say these two probabilities are actually equal. Probability Z less than or equal Z, simple Z, equal probability Z greater than or equal Z. Okay. So the now මෙතන minus. This should be minus Z. Minus C. Here minus Z. Okay. The same thing is given here as well. I mean, it's the same, it's a bit kind of the different way, but it's the same. Minus Z. Let me explain this one to you, the given one. So now let's take so here's the 0. Z as let me take negative 1.4. Okay. So we can find this probability value. So how do we write this one? Probability Z less than or equal negative 1.4. This is same as if we find, let's say here also we are having positive 1.4. If we find the probability, this part, this probability will be equal to the probability Z less than or equal 1.4. Okay, due to the symmetry. Due to the symmetry of the standard norm. So this is what's given here. Right? So once we know the probability Z less than this side, we can find probability C greater than to that same value, but in the positive value. Okay. So you should know how to handle the kind of the side. What I do, I just quickly draw this distribution, the shape of the distribution, and then by looking at the kind of the values, whether it's on the positive or the negative side, we can correctly find the probability. Okay, so you can also kind of quickly draw and see or denote the kind of the Z value and then find the correct probability from the given table. And then we are going to use this one with a couple of examples. So if you a bit kind of this is a new material, but we will use this one again and again. Okay, so don't worry if you miss some points, but you can ask if you don't get the idea here. Okay. Hi. Okay. Then we have another two concepts, the standardization and the linear transformation. I will discuss the standardization. So the standardization, it's a kind of a transformation. Actually, you will use this one in machine learning or whatever the tools that we are going to discuss under the predictive analytics. Standardization is a one transformation that we can use when we have kind of a skewed data. So standardization, how do the standardization? Simply, now we know the X values. Let's say we have X values from, let's say, 0, 1, 2 kind of values. Then if we know the mean and the standard deviation, so let's say, so this is the X value. Then what is the mean of X will be simply method 3. So 3 divided by 3, it's 1. What we do, we take the sum and then divide by 1. let's say variance or the standard deviation, let's say, let's assume the standard deviation of x is, let's say 2 කියලා. දන්නේ need to find, we need to find the value, but let's say, assume. So if we know the mean and the standard deviation, then we can convert each of these x value into z. How do we convert? We use this transformation. Okay, for the first one, අපි දන්නවා 0 minus mean divided by sigma, standard deviation. එතකොට මෙතන එනවා minus half. Then for the first one, this value, 1 minus 1 divided by 2, this is 0. So to make a ගන්න කොහොමද? 2 minus 1 divided by 2, this is half. So now we are having z values. Instead of the x values, now we are having the z values. So you see, we can use this standardization to kind of transform the given, the values of a given variable. So if we transform these variables, then the z follows a normal distribution. Then may x when we have a variable, a kind of a x variable, we don't know the distribution, but once we use this standardization, once we use this transformation, then we can say, okay, now the z value follows the standard normal distribution. So this is one way to kind of transform the skewed data. So let's say we are having very skewed kind of the distributed data, something like this. So if you want to make this into kind of a symmetric pattern like this, we can use this transformation, z transformation, or we can use this tree transformation or the standardization. Okay, so using this z transformation, we can make this skewed data to kind of a symmetric data. Okay, then the linear transformation, it's a kind of another transformation that we can use. Now let's say x, whatever the given variable follows kind of a normal distribution. Then let's say we are having a relationship between y and x with this constant y equal x plus b. Then as x follows the normal distribution, we can show that y also follows the normal distribution, but with some different mean and the variance. Mean will be simply a mu plus b, variance will be a squared sigma squared. We can prove this one, but just to kind of give you an idea. Right? So if we know the distribution of x, we can find the distribution of y as well. So y should have the relationship between something like this. Okay, then we are going to use this rule called empirical rule, or we call this one as 68, 95, and 99.7 rule. So let's go to the diagram first and let's see. Let me explain from here. So if simply this empirical rules gives the area. So if now here we are having kind of the normal distribution or the standard normal distribution. I mean, we can define the same for the standard normal as well. Then we are having mu, instead of mu, we are having 0. But this is for general. So mu is on the mu as the center value. So the probability between, now here, simply, if you look at this, the difference, here we are having plus sigma, at the mu plus sigma, this side, sorry, mu minus sigma, mu plus 1 sigma. Okay, so simply the probability between mu mu 1 sigma x mu plus sigma will be 68%. Then from here to here, we are having mu minus 2 sigma. Method mu plus 2 sigma. එකට අපි ලියුවොත් probability mu minus 2 sigma less than අපිට මෙතන greater than equal less than equal sign ගන්න පුළුවන් less than or equal x less than or equal mu plus 2 sigma වෙන්නේ 95%. 95%. Okay, then 99.7 will be mu minus 3 sigma, mu plus 3 sigma. So simply the area is given as the empirical rule. Let's go back. So for a given random variable x, the probability of x lying within the certain number of standard deviation from the mean are approximately. Okay, so when the mu, when the x is in between mu and sigma, mu minus sigma, mu plus sigma. Now, let me explain this to you here. How do we get this one? Now we know probability here, mu minus sigma, x, mu plus sigma. Now what I'm going to do, we know z, the transformation, c is simply x minus mu over sigma. What we are going to do, I'm going to kind of subtract mu from all of these values. Minus sigma, x minus mu, sigma. Then I'm going to divide all the terms between mu minus sigma and mu plus sigma. It's same as z is in between -1 and 1. Okay, so simply this is 68%. When mu x is in between mu minus 2 sigma, mu plus 2 sigma, so that means z is in between -2 and 2. This is 95%, and this is simply 99.7%. Okay, so c is in between -1 and 1, we are having 68. C is in between -2 to 2, 95. Z is in between -3 and 3, 99.7. So this is referred to as this rule or the empirical rule. It's not a difficult one, but it's given as a rule. Okay, now we are come to a couple of examples. Now what we are going to do here, we are going to kind of calculate the probability using normal distribution. Let's see how to do that. Okay, so here, suppose x required to assemble an item follows a normal distribution with mean. Now here we are given the mean. X follows a normal distribution. It's a time, actually time. X follows. අපිට මෙහෙම ලියන්න පුළුවන් here. එක ලිව්වනම් better. So x අපි ගමු. X is assembling time. X represents assembling time in minutes. In minutes. Okay. In minutes. So then අපිට දීලා තියෙනවා we have mu as 15.8 minutes and sigma, standard deviation sigma 2.4. Now what we are going to find? We are going to find the probability that the next item will take more than 17 minutes. Now let x is the assembling time in minutes. Then so now we write this given statement in using mathematical notation. Okay, so we can write, okay, probability, the assembling time take more than, greater than 70. So now we write this one. So then now what we do, now we have x greater than 70, and we are given this mu and sigma. So what we try to do, we try to convert this into z, because once we know the z, whatever the z probabilities, we can use our table. We can use this table because this table is given for the z values. So therefore, what we do, we convert this, whatever the x, the probabilities with this x variable into z. How do we do that one? We use the standardization. In the standardization we are going to use. Let's see how to do. So what we do, we subtract standardization z. To get z, we subtract mean and divided by standard deviation. Standard deviation. So what we do, we subtract mean from x and divided by the standard deviation. This is mean, mu, this is sigma. And we do the same for the right-hand side as well. So 17 minus mu, sigma. Now what we have? Now, instead of this part, now we are having z. Then z notation. And here, you can simplify this one. Now, z greater than 0.5. Okay, now once we have this one, we can use our table. So now what I'm going to do, I'm going to, let me use the slides here and then the table here. Otherwise, it will be a bit hard. Okay, now I'm going to kind of now use the table. Then අපිට table එක, you should understand the table values gives the area from left hand to the whatever the z value. The maker we should understand. Okay, the table. I mean, so you need to kind of see the definition of the table. I mean, sometimes we can have different standard normal probabilities, but for this table, we are having the left-hand side probability. Sometimes we have tables with the right-hand side probabilities as well. Okay, so depending on the given standard normal table, we need to consider the correct probability values. So now here, let's say we are going to use this table. හරි එතකොට මෙතන තියෙන්නේ left hand side area. Now අපි බලමු. දැන් ඔයගලන්ට තේරෙන්න ඕනේ මෙතන. Now here we have, so මෙන්න මෙතන පොඩක් you can draw. අපි ගන්නවා මෙතන අපිට 0 ගන්න පුළුවන්. Then now z 0.5 කියන්නේ somewhere here. අපි හිතමු මෙතන කියලා. Z somewhere here, and we are looking at z, z on the x-axis. So z greater than 0.5. Z greater than 0.5 can mean area. So we are looking at this area. Okay, so we are looking at this area. This is the probability z greater than 0.5. Okay. Now, how do we find this one? So our table gives us this area. The table gives us this area. Table gives us this area. Okay. We know the total area or the area under the curve, area under the whole curve is 1. So so 1 is the total area or total probability. So what we do, we find 1 minus this area. So if we take the difference, or if we subtract this area from 1, we are having the red one. So the area, how do we get this area? We go back to our table. Now this is 0.5. So 0.5 is here. And so we take this value. We take this one. This is the value. So simply we have 1 minus 0.6915. So this will be, so therefore the red area will be the answer. Okay. එතකොට මේ ටික ඉතින් you can skip these ones. ඒවා ගැන එච්චර worry වෙන්න එපා. So better, that's why I told you. So I just, I mean, my practice is just draw the this distribution and look at what is the relevant probability that we need to consider, and then using the given standard normal probabilities, we can find the correct value. So here now, I mean, you don't need to read this, write this one as well. You can directly jump into this step. If you draw this distribution, you can directly jump into this step. All right? Is it clear? I hope it's clear. Is it clear, Darwane? Let me go to then the next example. Let's see. Clear? Yes, yes. Okay, good. Thank you so much. Okay, thank you. Okay. Then the next example. Okay, so we are having kind of a bit, yes, okay, good. Kind of a bit, couple of questions. Okay, Harry. So now here, let's quickly read this example. We have here statistical analysis of 1,000 long distance telephone calls made from headquarters, blah, blah, blah. A length of this call, now X will be, let X as, so what is the definition of the variable? We should find that one from the given problem. So length of a call. Make a distributed normal with mean mu and the standard deviation 40 seconds. Sigma. We are having this. Then what is the probability that a call lasted less than? Put a make a probability X length of a call less than 180 seconds. Whether we are having the same units. Seconds. These are seconds and seconds. Okay. Now, second one, we are having the probability lasted between this one. It's 180. X is now in between 180 and 300. Okay, lasted between, again, X is in between these two. Okay, so we'll try to answer this one later. Then, once we write down the probabilities with this X notation, we can convert this one into Z. C. Here also we are going to convert these two with Z. So we need to find the values in these squares. Let me erase this one. Okay, yeah. So everything is given here. Okay, so let X be the length of the call, then X normally distributed. Now you know how to do this one now. You already know. X less than 180. What we need to do, we subtract mean and divided by standard deviation. We do the same for the right hand side. Then we have to make a inverter. Instead of this one, now we are having Z. Z less than negative 1.5. Negative 1.5. Now, then make a negative 1.5. අපි එක product draw කරමු. So here we have 0. Then අපි ඉන්නේ negative side. Negative 1.5. So we need to find this area. So this is the probability Z less than negative 1.5. But now in the table, we don't have negative values. Now, how do we do? By the symmetry or due to the symmetry of the normal distribution, we know this is same as this area. Make a positive 1.5 area. Honey? Area is the area of this part is equal to this one. Honey? Then make a kohomada you need to think. I mean, from the table we have the table from the table actually we can find this area. area table this probability Z less than or equal 1.5. We know it's here 1.5 here. Okay, it's actually 0.9332. Then what is this area? This blue one. Blue area will be simply probability Z make a greater than greater than 1.5. Make a 1 minus 0.9332. This is simply 0.0668. This is the value. This is same as make a tamaya probability Z less than or equal. You can take, you can ignore the equal sign or take the equal sign with the continuous distribution. Negative 1.5. So that's why I ask you to kind of draw whatever the region that we need to consider, and then we can see how to find the area or the probability value. Yeah, now it's 10:30. We have two more or three more questions. Let me delete this one a bit. Let's see what are the other questions we have here. Yeah, okay. So, type of sampling method is the topic that I want to discuss with you today. Anyway, we missed one class, so I will reschedule that one. So now you will have the tutorial. Uttara, are you there? Let's see whether Uttara is here. Uttara, are you there, Daru?
Yes, madam.
Yes, okay. Okay, so Miss Uttara is there. Now, Uttara, so you are going to discuss this normal distributions, right?
Okay, madam.
Is that the stuff that you're going to discuss today? Am I correct?
Yes, madam.
Yes, okay. Okay, so now, Daruane, Miss Uttara will take the tutorial class. You can start maybe from 10:45 again, for the break. She will discuss the other how to find the probabilities between these given two values, and how to find the x values. When we have the probability, when we are given the probability, and then from the probability, how do we get back the whatever the corresponding the value of the random variable. මේ part එක Miss Uttara කරයි. She will discuss this part, and then I hope she will discuss a couple of more questions. And then next week, Monday, I will take the Monday class. I will let you know the time slot. Monday, most probably the morning, I will take the morning class, and we will discuss the type of sampling methods. Okay, so I will plan is to kind of finish this part, and I need to kind of start or show you how to install our and our studio. Actually, it's given. You can go through, if you go back, or if you go down the slides here, setting up the R working environment. Here you are given the links to download R and the R Studio, and a couple of references as well. I mean, you can use YouTube video lessons to see how to install this one. So anyway, if you are already familiar with, then you don't need to worry, but we will see how to set up this R as well. You can download yeah, anyway, we will discuss this one next week. Then I can show you this stuff. What are the necessary stuff that we need to download? Yeah, okay. So then we'll meet again on Monday next week. So Ms. Uttara will take from here for the tutorial class. Okay. Thank you, guys. Then see you next week. And enjoy your day. We are using this same Zoom link. Okay, so you don't need to kind of log into another one. We are going to use the same. Uttara, maybe you can give a small break and start 10:45 again.
Okay, madam.
Yeah, hari. Okay, Darun. Thank you. Thank you, Darun. Okay. Thank you. Uttara, I'll give you a call.
Okay, madam.